Alright, in this video I'm just going to show you some example problems on slopes of tangent lines and also slopes of normal lines. Normal in this case meaning perpendicular. Alright, so we have this function. We want to find the slope of the tangent line at x equals 1. Seems simple enough, but a lot of algebra. Alright, so from the previous video, the slope of the tangent line is this limit expression. So first I have to substitute x plus h in everywhere where I see an x, and you get this nice big nasty expression. And replacing f of x with what it is, 3x cubed minus 2x plus 4, gives us this. Now for the algebraic details of how to get from step 2 here to step 3, you're going to have to look on my notes, okay? Because of the time limitation of the software I'm using here, I'm a little bit nervous about going over, and so again, check the notes for the details and how to get to from step 2 to step 3. Just a lot of multiplying out things and combining like terms, but eventually you'll arrive at this step if you do everything correctly, at which point we can reduce everything by a factor of h, and we'll get the limit as h goes to 0 of 5 plus 7h plus 3h squared. So now we're able to evaluate this limit using direct substitution and replace 0 with, or replace all of the h's with zeros, and we end up with 5. So the slope of the tangent line at x equals 1 is equal to 5. Alright, for the next part here, we're going to find an equation of the tangent line at x equals 1. Alright, so since f at 1 is equal to 5, and again, f of x is right here, and if you were to put 1 in for x into that function, you're going to get out 5. So we know then that the tangent line passes through 1, 5. We also know that the slope of the tangent is equal to 5 from part A. So putting these two things together, you can use point slope form to write down the equation of the tangent line. And again, it's assumed that everyone knows basic algebra and knows what point slope form of a line is. Okay, finally we're going to find an equation for the normal or perpendicular line at x equals 1. So again, this is just going back to basic algebra. We know that if one line has a slope of 5, that the perpendicular line slope is going to be the opposite reciprocal of that. And since the perpendicular is going to pass through the same line, this is going to be the equation. Alright, so just one more example. This one's actually a little bit simpler than the first one. We're going to look at the height of a ball in feet. It's modeled by this function. The context of the ball and the height will become relevant at the end. We're going to find the slope of the tangent line at t equals 1. Alright, so step 1, of course, is to just rewrite the limit expression with our two parts put in, the function evaluated at t plus h, as well as the original function itself. And then we're going to evaluate this limit. Again, in the interest of time, I've done the algebra on the notes, so take a look at that if you're unsure, but it eventually simplifies to this. And again, this is going to reduce by a factor of h to give us a limit that we can evaluate. And the slope of this ends up being -7.